Hello and welcome. My name is Tucker Davis. I'm with the Specialty Transformer Division of Southwest Electric, and today I'm going to be talking to you about the different types or methods of cooling for transformers. For distribution class transformers, there are two categories. That's going to be a dry type or an oil or liquid immersed. They're exactly as they sound. Dry type is completely dry with no liquid whatsoever in it. Those are not a product that we manufacture. We build the other one, the oil immersed or liquid immersed. And it is exactly as it sounds. The transformer is literally immersed in oil. So that's done for two reasons. First one is cooling. As the transformer is in operation, it will start to generate a lot of heat. And that heat needs to be removed from the transformer. And oil is a very effective way to do that. With your dry type transformers, those are only cooled by air. With oil, the heat capacity increases, so it can hold more heat and it can dissipate more heat to keep that transformer cool. Because if the transformer starts to get too hot, it will start to do damage to the insulation and will start to impact the life of the transformer, which we don't want. The core components of the transformer, all the circuitry is down in the bottom half of the transformer tank. So this is the enclosure that holds all the main components and also holds the oil. So as the main components inside the transformer tank start to heat up, it will start to heat up the oil around it. And as that oil heats up, it will start to rise and come up to the top or near the top of the transformer. That's where these come in. This is what essentially dissipates all the heat. So as the transformer oil rises, it will start to flow into these cooling fins, or what we call radiators, through these different headers. And as they come into these cooling fins, it will start to run down each individual fin as it can dissipate heat. So the more surface area you have on these, the more heat you can dissipate. As that heat is dissipated, the oil will cool down and actually start to sink to the bottom of the radiators. And then eventually it will make its way back into the transformer tank by these headers on the bottom side of the cooling fin. So as these transformers are running, oil is constantly circulating. It's natural convection that cools this transformer and keeps it running at a safe temperature for operation. So that's the first reason for using oil in a transformer. The second reason refers to what's called creep and strike. What those are basically the minimum amount of distance that must be maintained between two conducting components before they will try to connect electrically, either through the air or through a medium or along the surface of a medium. In open air, if you have those distances that are set, let's say for example this far apart, they drastically shrink in oil. So you can get conductive components much closer together in oil than you can in open air without risk of any arcs or faults or short circuit. So you can make a much more compact design. You do not need as much insulation, and it makes the transformer a little safer overall just by reducing those clearances needed between different conductive components. Visit us at swelectric.com to learn more.